Hello there. Let's continue with our simplifying radicals, but this time we're going to involve some algebra as you can see that there are now variables as part of the radicand. We'll begin the process the same way that we already know how to simplify radicals. Look at the value you have under the radical and we will create a factor tree for it. So think of two numbers you can multiply together to make 32. I think I'll go with 8 times 4 here. And when I consider 8, that's not prime. So I'll do that as 4 times 2. 4 is not prime. That can be 2 times 2. And I circle the prime numbers. On my other branch, I see I have 4. That's not prime yet. Split it up into 2 times 2. And here we have the primes. Now, seeing as how we have these variables, that's also going to be something for us to consider and worry about. For me, I like to spell those out into a prime notation just the same way as we do with the numerical values. Think about what x squared means. That's taking x times x, and then we're also multiplying it by y. There we are. So these prime numbers that I have circled in my factor tree, as well as these spelled out variables, are what I have to consider now as I look for my groups. So I'm talking about a square root. Remember that has the index of 2, so you're looking for pairs. You're looking for matches in groups of 2. Every time that you find a match, we're going to write it down once outside. When you find a match, we write it down once outside. The same goes for those variables. When you find a match, you write it down once outside. Anything that is left over without a match stays inside the radical. Our 2 that hasn't been used is going to stay inside, as well as that y that wasn't utilized stays inside. And now we simplify, multiply together anything that we can outside. That's going to be 4x, and multiply together any values you can underneath the radical. That'll remain a 2y. So you're talking 4x times the square root of 2y. Now, you don't have as nice of a way to check this as you did with simplifying just the numerical values, but you can still check the number parts in the same fashion. The Desmos calculator won't let you know if you've done your variables correctly, but you can type into the Desmos calculator square root of 32, and you can type into the Desmos calculator 4 times the square root of 2. And so you sort of ignore the variables for that part of it. It'll let you check your numbers, but you're going to have to be confident with your variable operations for that part. So let's go down below and we'll try out the number 2. Here we have the cube root of 32, x squared y to the 6. So 32 is kind of the same there. You could make the exact same factor tree as we did up above if you wanted. Maybe you want to change it up a little bit and go with a 2 times a 16. It's totally your choice, however you want to set that up. 16 happens to be a 2 times an 8. 8 happens to be a 2 times a 4. And 4 happens to be a 2 times a 2. Whatever version of a factor tree you choose, you'll write that out. And then I'm also going to look at my variables. X squared says that I'm multiplying x times itself 2 times, and y to the 6th says that I'm multiplying that y times itself 6 times. So I start looking for my matches. Check out the index. I need matches of 3. It's a cube root this time. So anytime that I find a group of matches, I write it down once. Now I've got some more leftover 2's, but do I have 3 of those 2's? No, I don't. My index says I need 3 of them. I only have 2, so that's not going to work. Look at my x's. Do I have 3 matching x's? No way. That's only 2 of them. Look at my y's. I have a group of 3. Write it down once. I have a group of 3. Write it down once. Anything that's left over stays inside the cube root. So my first 2 that's prime gets left inside. The second 2 that was prime gets left inside, as well as the x and the x that we did not use have to stay inside the radical. So we multiply together what we have outside. 2y, that can be rewritten as 2y squared. And then your cube root of, well, what's underneath? 2 times 2 is 4, and x times x is x squared. So you're talking 4x squared underneath of that cube root. 2y squared times the cube root of 4x squared is our simplified form here. We'll keep working our way along to that number 3. This time I need to focus on the square root of 48 UW. So let's make the factor tree for 48. Maybe I'll do 6 times 8. 6 I know is 3 times 2. so I can use that. 8 is 4 times a 2, where 2 is prime. 4 is not, so I can make that 2 times 2. And for my variables, I've got a UV, and so I'll spell those out, UV. So I go looking for my matches. You know it. Check out that index. It's a square root. That's an invisible index of 2. So find a group of 2. Every time you find a group, write it down once. Every time you find a group of matches, write it down once. Any other matches in here? No, doesn't look that way. So inside the square root, what's left over? What are the primes that we haven't used? The 3 was a prime that we didn't use. U didn't have any matches to go outside. And then variable V didn't have any matches to go outside. So multiply and clean that up. 4 times the square root of 3UV. That's what we're looking at. So how about this example 4? I'm going to take my cube root of 40, x to the 8th y, and let's make the factor tree for 40. So I'm going to work with 4 times 10. Maybe you prefer 8 times 5. Your choice. 4 is not prime. I can split that into a 2 times 2. 10 is not prime. That's got to be a 2 times a 5. And for my variables, x to the 8th, right? 1, 2, 3, 4, 5, 6, 7, 8 of them, and times a y as well. So I start looking for my groups. Is it a square root, cube root, fourth root? What are we doing here? Cube root it is. Look for a group of 3. Every time you find a group of 3, write it down once. Every time you find a group of 3, write it down once. And when you find a group of 3, write it down once. Anything that can't make a complete group of 3 stays inside the radical. Don't forget that index. Got to keep it as a cube root. But 5 didn't have any matches, stays under the radical. X and X did not make a complete group of 3, so they need to stay under the radical. Y does not have a group. That stays under the radical. And so we clean it up. Multiply where you can outside. 2x squared, and multiply what you can under the radical. Cube root of 5x squared y. There you are. Now, I'm wondering if at this point you noticed a little bit of a pattern or a little bit of connection about the exponents on those variables. And if you are comfortable and understanding about writing out those variables to see how many you have and looking for the groups to figure out what's outside or what's inside the radical, that's totally fine. Here's another little connection that you might make. This x to the 8th, and we were looking for groups of 3. So you're actually thinking to yourself, like, what if I do 8 divided by 3? Right? 3 can go into 8 2 times. And what do? You multiply back and get a 6, subtract, you get a 2. So then you'd have a remainder of 2/3. Exactly. So where do all of these numbers go? How do these pieces fit together? When you do that division, the whole number is the exponent that can come outside, and your numerator of the remainder is what you have for the leftover inside part. And that'll work on all of these types of problems for you. If you see that connection, wonderful. If it's not really making sense to you, okay, then you don't have to worry about that. You can certainly use another strategy. So let's try this number 5 example. 675. And when I look at that, knowing that it ends in a 75, I should be able to divide that by 25. So this is 25 times 27, actually. 25 is 5 times 5. 27 I know is 9 times 3. So in that I've got a prime 5, a prime 5, and a prime 3. Keep going with that 9. Got to work it until it's prime. 3 times 3. And for my variables, again, I'm going to spell them out here, but when we're done, we'll also go ahead and look at how that division can clue you in with it. So it's a square root. I am looking for groups, looking for matches of 2. A group of 5s comes out as 1 match. And a group of 3s gets written outside as 1 match. Look at my x's. A group of x's gets written outside as 1. And then we've got the square root of, well, let's see. Oh, hey, look at that. I got a little carried away. Did anybody catch it? The y's? I almost missed them. A group of y's can also be written outside. So it's just this prime 3 that we have staying inside the radical, and the last x stays inside the radical. So then we can simplify 15xy times the square root of 3x to be that final answer. So let's take a look, just like we did in that last one with a little bit of division, and see exactly how those variables are relating with each other. So my x to the 3, right? So focusing on x here for this part. So my 3 is divided by, what was the index? 2. So 2 goes into 3 one time, multiply it through and I get a 2, subtract and I get a 1. So that's a good, would be a 1/2 remainder. So notice in there, your whole number is what you have as the exponent outside, invisible 1. And then the remainder for that numerator is what we have on the inside of the radical, again, an invisible 1. Let's check that out if it works the same way with the y's. I had y to the second, so that exponent of 2 is being divided by my index of 2. 2 divided by 2 is 1, multiply 2 times 1 is 2, subtract and I get a 0 remainder. So how does that work? My whole number is what goes outside, invisible 1, and my remainder, look at that remainder. There is no remainder, so that tells me there is going to be no y value underneath of the radical with it. Okay, go ahead and try out the other 5 problems that are on this sheet of examples. Pause the video so you can do that, and when you're ready to check your answers, turn it back on again. Now that you've given those last 5 problems a great try, here are the answers that you should have gotten for numbers 6 through 10. Take another look at those and compare with what you already got. I hope that you worked them out well, but if not, feel free to erase and try them again. Ask a neighbor or check with your teacher if you need some extra guidance on how to work some of those out. Hope that you're feeling a lot more confident with these factor trees and being able to write in simplest radical notation. Have an awesome day. Now that you've given those last 5 problems a great try, here are the answers that you should have gotten for numbers 6 through 10. Take another look at those and compare with what you already got. I hope that you worked them out well, but if not, feel free to erase and try them again. Ask a neighbor or check with your teacher if you need some extra guidance on how to work some of those out. Hope that you're feeling a lot more confident with these factor trees and being able to write in simplest radical notation. Have an awesome day.